There is no such thing as a magic pill in chef. If you listen to this talk thinking that I'm going to give you a magical one-fits-all solution that you can just stick into your infrastructure and it will solve all your problems, you're going to be very disappointed. That's not the way chef works. What I'm aiming to do in this talk is to give you some ideas, some tooling, possibly some new ways of thinking that will help you to get more out of chef, and hopefully you'll adapt the stuff I'm telling you for your own workflows rather than adopt it verbatim. So, on to the main talk. Quick summary of how we use Chef Etsy. We use open source Chef Server not 10.4. We're a couple of versions behind mainstream. We back up to the Ops Code platform. We don't actually use it to run our nodes off. It's kind of a disaster recovery thing for us. We have roughly 800 nodes, all of which we host ourselves, mainly CentOS, some Red Hat Enterprise, some Mac. Virtualization-wise, we mainly use KVM, although we've started rolling out some LXC containers in our CI environment. Those are all hosted ourselves as well. Basically, we prefer bare metal for all of our user-facing stuff. We do use the cloud for some things when it fits the circumstance, but a lot of the stuff I'm talking about today is from the point of view of servers we host ourselves. So I'm not going to touch very much on, for example, EC2, Rackspace Cloud, that kind of stuff, mainly because we don't really use it that much. Going back to what I said about there being no panacea, everyone uses Chef differently, so this is kind of where I'm coming from. Another critical thing about our particular use of Chef is a point everyone should be doing, which is never testing in production. Those of you who went to ChefConf may have seen my colleague Patrick's talk, which went into this in a lot more detail. But it's very, very important to never test things in production because they'll break all of the time. Another thing I'll touch more on that's kind of a bit more specific to us is the idea of many chefs not spoiling our soup. I promise this is the last food-related pun. We have a lot more than most people committing to our chef repo, which touches on a lot of the workflow stuff I'm going to go on to in a little bit. So, familiarity and understanding. This is basically a summary of this entire section. The theory being, chef should feel like the comfortable pair of boots that you see on the left, that if you're going to do some kind of operations-related task, you put on your comfortable pair of boots, you do your task, job done. You know, it's a trusted, reliable pair of shoes that gets you anywhere. The pair of shoes on the right, I found on Google when I searched for stupid shoes. So, pretty much says it all, really. They look like some kind of weird alien thing. They're quite shiny. It looks like, quite a lot of thought went into how to design them. Can't really do much with them. You might wear them to a party once. It will probably break your ankle, and then you'll never use them again. Sometimes when you're starting with Chef, because there's so much content and there's so many ways to do things, it can feel slightly like the pair of shoes on the right, which you would never really do anything particularly serious with. What I want everybody to feel like is Chef is your comfortable, trusty pair of boots. That's the first thing you reach for when you're going to do something. So this section's broken down into 4 kind of areas. The first is insight. This is talking about monitoring Chef, how to introspect into what your Chef infrastructure is actually doing under the hood, which is something that at the moment it doesn't come with that much of out of the box. I'm going to talk about the idea of simplicity. This is keeping things as simple as you can when you can, but recognizing when you can't and how to cope with that. I'm going to talk about the importance of standards as well. Not going to talk so much about testing, mainly because this is only a 90-minute talk and there's a lot of stuff to go over in testing. So I'm going to focus more on standards, which is particularly from the point of view of if you're a guy or a girl working for a small startup, you might not have time to write functional tests for your entire Chef infrastructure. So this is going to focus on some quick wins and also how important it is to have standards and why. So on to insights. You should never have to say, I don't know, when someone asks you a question about Chef. If you're getting questions like, what just failed there? Where are these cookbooks failing? When did things start breaking? Why are they breaking? How long have all these servers been failing? This is all stuff that you should be able to answer. It sounds like it could be difficult, especially if you've never had to do it before. It's actually really easy. All the stuff I'm going to show you in this, I've basically done a little slide with instructions for how to get it working. It's all open sourced as well. So kind of taking a top-down approach to how we introspect a chef Etsy. This first slide is our chef dashboard, one of many, many dashboards we have. Those of you who've seen Etsy talks before will know we really do like our metrics. It's a little bit small, but what you can see on the top 3 graphs are just Apache response time graphs. The 5 graphs below are average elapsed runtime, maximum elapsed runtime. Then there's all elapsed runtimes, including outliers at the top and things like that. And then there's a couple of graphs for our ratio of successful to failed chef runs, and a graph of how many resources we're updating across the board in our chef runs. This dashboard is built, or the core of it is a chef handler, which sends metrics to Graphite. I've put the footnote there, so you'll find it in the resources document where to download this handler from. It's all open sourced. If anyone wants to try getting it running, it's just as simple as cloning from the Git repo. We've open sourced all our handlers into the same repo. I'm going to cover 2 of them here. They're all in that repo if anyone wants to have a go at them. All you have to do to get this working, providing you already have Graphite running, is set your Graphite server's URL in graphite.rb, which is the handler file. Add the following 4 lines to your client.rb file. It's just a require and then setting up the handlers. And that's essentially it. You're now sending metrics to Graphite from Chef. And you can generate all of those graphs. Now, this is done, the dashboard I previously showed you is done using the Etsy Dashboards framework, link number 5. Literally last night, we open sourced the newest, shiniest version of that, which includes the code for the dashboard you just saw. So if you want to use it, you can find it in link 5 in the footnotes. You can download it, you can get it up and running, and you can have that dashboard done by the end of this talk if you already have Graphite up and running. It's that simple to do. There's no ninja coding behind the scenes. You just have to change a couple of parameters, set the URL in the dashboards file, and it's that simple. You've now got a dashboard that shows you a whole bunch of stuff about Chef. So that's the first stage of insight. That gives you a good idea when you're having a problem. If you get a spike in failed runs and successful runs plummets, that's a good sign there's probably something going wrong. The next stage, once you've got a problem, is identifying where that problem's happening. So this is what we have in our Chef IRC channel. It's just a little alert that says every time a chef run fails, it will tell us what box it failed on, and it will also give us a gist of what the exception was. It's really handy. You can just see if you've made a change and all of a sudden a bunch of servers are failing. You can see that. Again, this is done using a chef handler. It's in the same repository as before. It uses the IRC cat bot, which was written by RJ from Last.fm. All you have to do is set your IRC cat server's URL in log to IRC. IRC cat, for anyone who hasn't used it, is just a little bot which you can send stuff to over a TCP socket, and it will write it to your IRC channel of choice. Add the following 2 lines to client.rb, and now you've got that behavior as well. If you've got an IRC cat server set up, you've now got all of your chef nodes telling you when they fail. The next thing, that's all very well and good, but say, for example, you've got an infrastructure where you've got a lot of servers, you haven't quite had time to chase down all the errors, and you've got, a couple of hundred error messages coming every run cycle into your chef channel. What do you do about that? You've looked at one, you've seen, oh God, I just screwed up the PHP cookbook. Did you break it for everything, or did you break it for one box? Is it one box that has a special config? How do you tell that? Which brings us on to the next tool. This is a knife plugin written by one of our engineers, Jon Cowie, who is here at the moment. It's called Knife Last Run. What this does is actually very simple. It takes the same data that you get in the exception log and in the gist that we showed you before, plus a couple of timestamps, and it stores it as node metadata. Now, what you might initially be thinking, as in fact I initially thought when I first saw this plugin, was why are we now duplicating the data? It's already in the log file, it's already in the gist. We're now storing it on the node as well. We're just storing the data 2 or 3 times. The cool thing you can do with this is now that you have the data on the node, you can search it. So just by having that data in place, the scenario I gave you before where you've got 200 nodes failing, you can look at one of them, take the exception that it had, and you can instantly search across all of your nodes to find out how many of them are failing with the same error. So what we're doing here, the error we saw before was a chef exceptions package, so it was a packaging error. What we're doing here, for anyone not familiar with knife searches, is we're searching all nodes for the last run debug formatted exception attribute, where it contains the text chef exceptions package, and we're then filtering to only show the formatted exception attribute, which found 5 results. I've snipped the last 3 because they didn't fit on the slide. What we can see is we have 2 here. We have master restore, which is failing with a Postgres error, and we have build test 11, which is the culprit, which is failing with version 5.3.10 of PHP not found. What we've now discovered is that although we may have had 200 error messages, we haven't actually screwed up the entire PHP cookbook. There's probably something special about this box that for some reason that package install isn't working. That's taken us from having to trawl through, client.log on all of our boxes and having to look through every single gist in our IRC channel if you have that, to running one search query that's just searched our entire infrastructure for nodes failing for the same reason. The one caveat to be aware of here is that data is only updated every time the node runs. So if you've pushed a change and you've thought, oh, okay, that's only affected one box, and your other 700 haven't yet run, they might not be showing the error yet. So if you do decide to use this, just something to be aware of. How to get this set up? Again, it's open sourced. It's a combination of a chef handler to actually store the data, the node attributes, and a knife plugin to read it. It's on Ruby gems, gem install knife last run, simple as that. On the handler side, add the following lines to client.rb. Because the handler is packaged with the gem, if you do use this, you need to have the gem installed on all of your nodes for client.rb to include it. Again, once those 4 lines are in your client.rb, that's essentially it. This is now working. You can now do all of the stuff I just showed you. You can run the searches. You're storing all that data on your nodes. How you actually use the plugin once it's installed: knife node last run, name of node, and it will give you the output I showed you there. And again, you can search against it. So what that's essentially doing, that's taking us from an out-of-the-box installation of Chef, where you have a bunch of log files and you have to do some clever grepping if you want to find stuff out, to we now have graphs that show you how Chef's performing, what ratio of success to fails you're getting, how long your runs are taking. If you have a massive spike in run times, you might want to have a look into why that's happening, for example. You can see that on the graph. Once you've identified there's an error happening, you can see what servers it's happening on. And then you can also search deeper to find out if it's definitely only those servers or if you missed one of the errors scrolling past in the noise. Which I'm hoping, even if you don't decide to use these tools, just the fact that it's a case of adding a couple of lines to your client.rb file to get this level of insight into how Chef works. It's not that difficult to do. Have a look at actually what underpins this, the code in the handlers. Most of them are 20 to 30 lines of code. They're just taking the attributes that Chef exposes to you in code, and they're storing them, or they're doing something with it, or writing a message to somewhere. This stuff is easy to do if you don't use IRC Cat and Graphite. If you use, for example, Sensu or one of the other graphing frameworks. Someone's actually recently published a Ruby gem, the name of which escapes me for the moment, which essentially does the same thing. It lets you send metrics to other graphing frameworks, and you can extend it as much as you want. Getting this insight into Chef doesn't have to be hard. This is one way we did it. You might have different use cases, but it's a very, very powerful tool, and it gives you a lot more insight into what Chef's doing, especially if you're running a large suite of servers, possibly even, in the cloud, where you don't have direct control over the hardware itself. All this stuff works on Opscode platform as well. None of it is dependent on you hosting your own hardware. It's all stuff that runs in the Chef space. So if you want to stick this on Opscode platform, you can still get all of this insight into the way your nodes are working. What I want to move on to now is simplicity. Essentially, think of yourself at 3 a.m. Although many of us are, to some extent, developers, given we're all here, we're probably at least familiar with the term DevOps. Most of us can code to some or greater or lesser degree. The difference between our coding and developers' coding is when our code breaks, we get paged at 3 a.m. because of it. Especially if you're writing chef cookbooks, which can essentially be quite complex code, and your cookbook's gone wrong, and you get woken up. You're then going to have to try and remember what you did and how you made it work at 3 a.m. when you've just woken up. Also, if you have a new person start, it's essentially the same thing as you waking up at 3 a.m. You've got a new guy started, or new girl, You have to then explain to them how your marvelous ninja chef cookbook works and all of the cool stuff you made it do. They're going to have to try and maintain that. It's essentially the same thing, like I said, as you waking up at 3 a.m. It's the same kind of level of having to get to grasp with something you don't totally understand. So minimize the logic. As few logical steps from start to finish in your cookbook as possible. It's possible to do it in really cool, shiny ways, but if you can't fix it at 3 o'clock in the morning, that code is essentially worthless to you. You don't understand what it's doing. You maybe did once when you wrote it, but if you don't understand it at 3 a.m., 2 years when that code's finally done something wrong, that code is useless to you. I'm now going to give you an example of what can happen if you don't follow these steps in the form of a git commit. The git commit is essentially unreadable, which is kind of as intended because it's horrible. Dates from December the 5th, 2011. The commit message was so close to death. This commit was the logic that we used in our SyslogNG Cookbook to stop us from installing it on CENT56 machines. It started off as a simple control statement. If the node fqdn isn't in our pre-production environment or doesn't include search or whatever, do this, otherwise do that. And you can see the result. This commit was essentially just adding another tiny little regex for a particular group of hosts to that control statement. It worked perfectly well, but at 3 a.m., when you're trying to figure out, did that server I just built fit any of these 40 or so regexes, that's not going to be fun. You're just not going to be able to do it. Needless to say, this commit is now gone. It does not exist anywhere in our infrastructure, and it never will again. But this is an example of when simplicity with the best of intentions can spiral. If you end up approaching this situation, if you've got some simplicity in there and it's not working, or it started spiraling out of control, rewrite the damn cookbook. It's going to take you time, but when you have to try and fix it at 3 a.m. or 6 months down the line, when you're trying to explain to your new ops person how the regex for this particular group of servers works and how that regex beside it kind of looks like it but isn't quite it, and all of that kind of stuff, you'll thank yourself for having taken that time. So this is a little example of what I mean when I say simplicity. This is actually existent in our chef cookbooks at the moment. This is something I'm using to upgrade libmemcached across all of our web nodes. This code is essentially very simple. It's upgrading it on one group of nodes but not on another because we want to obviously do a gradual rollout. There are any number of ways we could do this. I would bet a fair amount of the people in this room could each suggest a different way we could do this. But I'm just using this as an example of doing it simply. It's slightly more long form than it could be as well. For example, we could abstract out the version number to a parameter, but in my opinion, it just makes it slightly harder to read. What we essentially have here is one logic step that controls how this recipe works. If the node environment is libmemcached upgrade, install the new version. Otherwise, don't install the old version. All I need to do to upgrade a node is move it into an environment, and then it upgrades the package. Like I said, there's one logic step in this. When you wake up at 3 a.m. and you're thinking, oh my God, how did I upgrade memcached on that server by mistake? You only have to check one, providing this is the only cookbook you actually have this package block in, that's the caveat. All you have to do is figure out whether you broke that one condition if the node's in that environment. Maybe you accidentally moved a node, for example. There's no nested control structures or regexes or kind of huge blocks of Ruby code doing all kinds of elegant things. It's simple. If you have to try and explain this to your new person, even if they don't know Chef, providing they're familiar with sort of semi-basic programming, we have if, else, end. If one condition, do this, otherwise do that. Even if they don't know exactly what it does, it's a little bit easier for them to get their head around because we're not doing anything too complicated. Now, this kind of maybe sounds like I'm telling you not to do any of the cool things that Chef can do, which isn't the case at all. Sometimes it's not possible to have that level of simplicity. We work in operations. We work with incredibly complex software, incredibly complex systems. Sometimes you need complex behavior. With all the will in the world, you can't reduce your cookbook to a single control statement. So don't fight the complexity. If you're in a situation where you have complex software with multiple different configurations across multiple different servers, don't fight it. Don't spend your time trying to cut out all the logic and end up with a massive long 300-line recipe. This is no use to anyone. Abstract the complexity out. Reduce the complexity to a single point which you can document. It's understood that the complexity exists in this one place. It's not spread throughout your whole cookbook. What I'm going to do to illustrate this is I'm going to talk about a refactoring we did of the aforementioned SyslogNG Cookbook, one step of which was removing that regex and smiting it from the face of existence. This is what we started with when we entered this refactor. Our SyslogNG Cookbook had 36 recipes, 30 individual versions of syslogng.conf, which is the client-side configuration file, 27 manually configured files of the server-side configuration, which specifies what logs come from what servers and go where with what filters. Edge cases and exceptions all over the place. We had servers doing, one particular server in a group doing one thing, others doing others. The other issue here is with syslogng on the server, for those of you who haven't used it, when you're declaring a filter, for example, all the web nodes that have the logs tagged Apache access log, that filter has a name, and that name has to be unique. If you have 27 manually configured files, and you're adding yet another server's Apache access logs to your syslog host, and you accidentally put in the wrong filter, or a previously used filter name, syslogng will either break when you try and restart it, or it will take one of them and ignore the other, depending on use case. This cookbook was a nightmare. When I started at Etsy around about last August, this cookbook honestly made me want to cry. Because I had to use it, because I was getting used to all the systems. I was starting to do reasonably simple tasks like, oh, there's a ticket for adding this log file on this server to syslogng. Shouldn't be a difficult task. It's just adding an extra couple of lines in your syslog configuration. If you have a cookbook like this, it can turn into a fairly hellish task. I've had to then explain it to another newer member of the team, and it's a horrible thing to have to explain this cookbook. So what we refactored it down to, what we have now 2 recipes. We have one recipe for the client-side configuration. We have one recipe for the server-side configuration. We have 2 templates, one for syslogng.conf, one for stuff in syslogng.d. How we manage all of this, where we abstracted the complexity, is all of this is managed using attributes in roles. This is the one part which isn't open sourced yet. It will be, I promise, but I'm my own harshest critic, and I didn't think the code was quite clean enough to show off in a section where I'm talking about simplicity. So I want to clean it up a little bit before I open source it. So here's an example of what I'm talking about when I say attributes. Now, initially, this might look quite daunting. We format all of our role files in JSON, so this is a blob of JSON. We have the group variable, which is pre-prod web. In this case, this is our pre-production web servers. Then we have an array of all of the log items we want to configure. So in this case, we're dealing with the Apache access log. We have 2 source attributes which configure the client side. It tells you where the log file's coming from and what tag you want to give it when you send it to the server. Then the destination parameters manage the server-side configuration, what will end up being put into syslogng.d/foo. We have the destination, which tells you where you want the file to end up. The filters you're using to gather from clients, any pre-prod web hosts with tag Apache access, and then we're setting the template escape no destination option. Now, this is still kind of semi-complex. It does need you to know, how SyslogNG works. It needs you to understand what filters you're going to use and that kind of stuff. But this is what I mean when I say unavoidable complexity. We have 800 nodes with, we legitimately have probably 27 or 28 different syslog configurations on various different servers that do various different things. That's kind of unavoidable. In some cases we have software running on one box, but not others. It has to be that way. So what we've done here is we've abstracted the complexity and pulled it into one place. The complexity now only exists as attributes in our role files, rather than in templates, recipes, cookbook files kind of spread all over the entire thing. We've got a page on the wiki which documents how to format this block, what all of the parameters are, there are some optional ones, and what they support. So if somebody knew, or I have to then fix it at 3 a.m. when I screwed something up, I don't have to try and figure out which of the 27 recipes is actually the one causing the problem. All I have to do is I have to go and look at the block of JSON in the relevant role file. I can then go and cross-match it with a wiki page to check I haven't spelt a parameter name wrong, or it was expecting an array and I passed it a string, for example. It's in one place. If I then have to explain this to somebody new, I can point them an existing role file and say, this is an example of the block. Here's the wiki page that gives you all the parameters. It abstracts it out to one manageable place, which when you wake up at 3 a.m. and you think, and say for example, Syslog's screwed something up on your web servers, all you need to do is go to the web role, look at your syslog attributes. This is kind of what I mean when I say sometimes you can't keep it simple, but you can kind of simplify the complexity. Make it easier for yourself to fix this stuff at 3 a.m. Put the time in so you don't regret it 6 months later and wish you had when you've just got paged for it. Reinforcing a previous point, there are no panaceas in Chef. What I just talked about, may not work for you. This is all about giving you the ideas. One of the things I want to go on to talk about slightly further in this section are software upgrades, which are one of the most lamented aspects of being a sysadmin, I think. They're hard to manage. Do you have a policy? When do you upgrade? When don't you upgrade? Do you upgrade automatically? Do you upgrade manually? Do you upgrade security patches? So a couple of questions. A new package has hit the repository. Are you in control of when that package goes out? Do you know when that package will be pushed to your servers and when they will install it? An example of when we got this wrong was an outage we had with Memcached, whereby a new Memcached package was published to the upstream EPEL repo. We then synced it down to our internal repo, and because we'd installed Memcached in Chef with Action Upgrade, it automatically updated the package on our servers and it wiped out our entire Memcache cluster, which then caused all of our web servers to thrash. It caused our master database server to be doing several 100,000 queries a minute. It was horrendous, and it was caused by one line in Chef being Action Upgrade instead of Action Install. Even if you control the upgrade, do you know what services are going to be restarted and when? Are they going to be restarted with the package installed? Do you have to do it manually? Will they be restarted when logrotate runs at 4 in the morning? Another example I'm going to use here. If you want more detail on this, by the way, I've linked in the resources sheet to Patrick's talk I mentioned at ChefConf, which goes into a lot more detail about what caused these outages. This particular outage was caused by logrotate running at 4 in the morning and hard restarting Apache, which had some syntax errors in its configuration, so it essentially didn't restart. What this caused was every image on Etsy.com to not be displayed, just because of logrotate running at 4 in the morning. This is caused by very simple stuff. And the thing is, with all the will in the world, it's impossible for you to catch them all. So what I want to talk about now we've got through the idea of simplicity, is the importance of having standards. Now, as I mentioned before, I'm not going to talk about testing here. I've linked to 3 really good talks that cover testing in a lot more detail. There's a couple of episodes of the Food Fight Show podcast, and if I remember correctly, there's also a link to a ChefConf talk that goes into more of the functional testing side of things, using Chef Spec, Cucumber Chef, that sort of thing. What I'm going to talk about here are standards and sort of best practices, if you will. How you want your cookbooks to be written and how you make sure people write them that way. So if you've written your beautifully simplified cookbooks, somebody doesn't come along and start automatically upgrading packages across your entire infrastructure. To which I hear you cry, but I don't have time for standards. There's only one of me. I work at a 5-person startup. I don't have time to write some magical tool that standardizes stuff. I don't have time to communicate this to people. So what I'm going to demonstrate to you is why that isn't actually the case at all, and how it really actually won't take that much time to get a quick win. I won't say that you should make time, because as anyone who works for a startup or a small company or even a big company knows, having somebody tell you to make time for something is one of the most frustrating things to hear in the entire world, because you're already working 11, 12-hour days. You don't have any time. So for quick win, I want to recommend Andrew Crump's awesome tool. If you ever meet him, buy him a beer, because the man is brilliant. He wrote a tool called Food Critic. What Food Critic is, to use programming terminology, is a linter tool. It runs over your cookbook and it analyzes the syntax tree and it lets you write various rules against it. Food Critic comes with really good out-of-the-box rules to pick up some of the two categories of things that might screw up your cookbook, and what you might call style rules, things that are perfectly valid but may be better written another way. So even without writing any rules yourself, just using Food Critic will get you a long way towards having standards and avoiding 4 a.m. screw-ups. If you use Jenkins CI system, you can integrate it with Food Critic in literally seconds, at which point you now have a build running a lint check on your chef cookbooks, which you can set to email or whatever if somebody pushes a change that breaks. You can write your own rules. This is something we do. I'm going to come on to this slightly later in the section. Every time we have an incident in Chef, like the ones I discussed where we were upgrading packages when we didn't realize we were, we write a Food Critic rule to stop us doing it again. And that links in with our workflow. We've got a kind of slightly customized workflow, which I'm going to talk about in the critical approach section. So we've linked in that with Food Critic as well, so that we can make people comply with our established best practices. We've already discovered action upgrade can be a dangerous thing if you don't know what it's doing. We don't want to learn that lesson again. We already got woken up by it once. So Food Critic. It's very simple to install. It's a Ruby gem. Gem install Food Critic. You now have Food Critic. You can run the Food Critic binary on your cookbook repository, and it will then check all of your cookbooks with all of the default rules. Simple as that. To integrate it with Jenkins, you create a Jenkins job, which runs the following bash script. What the -f correctness part does is it says, in this case, you only want the job to fail if it's a correctness rule, i.e. one that will break your cookbook that has been broken. If it's a style rule, it will warn you, but it won't fail the job. What you've essentially done with those couple of steps is you've now got standards. You didn't have to write them yourself. You can if you want, but you didn't have to. You're now checking that people are complying with best practice. You can make your own rules like we do when you have an outage. And it didn't take hours and hours of your time and involve reading books and going to a course on how to write brilliant specs and that kind of stuff. It's a simple, quick win that can help you so much. Hopefully I can demonstrate that slightly better later when I show you the kind of rules we're using. All of our rules are style rules, not correctness rules, because they won't break your cookbook, but they might break your infrastructure. That's probably the best way of describing a style rule. It's a syntactically valid cookbook, but it might not be written in the best way, and in the worst case, it's going to get you paged. So we have a whole bunch of rules, specifically 7 of them at the moment. I'm not going to talk about all of them because some of them aren't as a result of outages. They're just things we've decided we don't want to do. For example, number 2, using the execute resource to run Git commands instead of the built-in SCM resource that Chef provides. I'm going to specifically talk about the 2 of them that refer to the outages that I talked about earlier on. Rule ETSI 001, written after the aforementioned memcache outage. Package or yum package resource used with upgrade action. It's a very simple rule. We basically decided we do not want to use action upgrade anywhere in any cookbook. We decided, again, this may be different for your company, we decided we do not want Chef automatically upgrading software. This is an example of This is the exact code which caused that outage in our cookbook. 3 simple lines: package memcache do, action upgrade, end. That's all it was, and it took out our entire memcache cluster. Now we have a rule, which means you can't do that. If you try and do action upgrade, it won't let you our tooling won't let you upload your cookbook. So we've now eliminated, well, at least minimized the possibility of this happening again. Next, we have rule ETSI 005. This is written after the total image service outage, which is sending action restart to a core service. We've defined a list of what we consider core services. So this would be, for example, Apache, MySQL, Memcached, PostgreSQL, things like that. If you want to send an action restart to NTPD, we don't really care. If you want to send an action restart to Apache on one of our front-end web servers, we very much care. So this is an example of a fairly standard way of pushing a cookbook file out to pushing a vhost configuration file out to Apache. It's just a cookbook file resource. Notifies restart, resources, services, HTTPD. It's pushing out a file, it's restarting Apache. Reloading Apache will give you the same effect and won't cause this issue. So that's what we personally recommend. But again, your mileage may vary. What I forgot to mention was all of our Food Critic rules, which are listed here. Number 9 on the resources list. These are all open source. They're on GitHub. If you want to run these alongside the existing Food Critic rules, they're right there. You can grab them. You can use them in your own infrastructure and avoid the outages that we had. Let's just jump back forward slightly to where I was. So that ends standards. We've covered simplicity and standards so far. Insight, simplicity, and standards. Combined together, all three can give you a lot more confidence that you understand what Chef is doing. Chef's a complex tool. It's very important that you're not the person sat there thinking, I don't understand why this is breaking. There are many different ways you can do it. I've given you examples of 3 that have worked very well for us. Hopefully this will give everybody some ideas for stuff that might work for your particular use case. I want to expand on that slightly now by looking at critical approach and experimentation. Chef is by necessity a generic tool. Opscode have written Chef to work for everyone in every infrastructure in an ideal world. It works on Windows, Linux, Mac, etc., etc. It's written to be as close as we can get to a one-fits-all solution for everyone, for every piece of software you run. So you can, in-house software, you can write a cookbook for it. But like I said, as a result, this means that Chef is generic. Chef is not customized to your workflow. What Opscode have done is they've tried to satisfy the use cases of most people. That doesn't necessarily mean you're one of them. So don't take Opscode's word for it. If something in Chef doesn't work well for you, change it. It's an open source product. Opscode don't know best. Opscode are trying to satisfy most of you. That's not going to work for all of you. You have the power in your operationally minded hands to change Chef to work for your infrastructure. You are the expert in this room on your infrastructure. No one in this room knows more about your infrastructure than you do. Not me, not Opscode, not anyone else in the audience. You are the only person who can make Chef work the way you want it for your infrastructure. And that includes extending it if you have to. What I'm going to look at in this section is what at first sight seems like a fairly innocuous example, how we rolled out environments at Etsy. Environments, for anyone who isn't using them, were released in Chef Not 10, and it lets you specify versioning constraints for cookbooks for particular groups of servers. The environment rollout project was done round about the beginning of 2012. We knew we needed environments. The situation we were in was we had our production stuff running off of an internally hosted Chef server, and all of our development stuff was running on Opscode platform. This meant we had 2 separate Chef servers, we had 2 separate knife configuration files. We had to try and keep both of them in sync, which is a next to impossible task when you have as many people updating Chef as we do. What we wanted to do was consolidate all of that into one Chef server. So there's one knife configuration file, and you didn't have people trying to upload stuff to development and hitting production by mistake, thinking they'd upload it to production, and actually uploading it to development and production still on an old version of software. Simple enough. Environments are easy. It's a list of version constraints in a file. But let's look at the workflow that environments ship with. This is the out-of-the-box standard workflow that, if you read the environments wiki page, you'll get. Typically, you might look at the version number your cookbook already has. You might increment that version number in metadata.rb, change the corresponding version constraint in your environment JSON or environment.rb file, just changing a number. Commit and push your changes to your version control system. Upload your cookbook, possibly freeze it as well. For anyone who's not familiar, --freeze essentially locks the cookbook when you upload it so that you can't upload the same version number twice. Then you upload your environment file. This is the standard workflow, and in most cases it works very, very well. But there are situations, including ours, where it doesn't. We have 41 people with access to our chef repository who can commit and push changes. Most of those people have knife keys. They can all push changes to production chef. Every single one of those people was editing the same 2 files with every chef change. The way we use environments, we have our production and development environments, which are rigidly locked down with constraints, and we have an unconstrained testing environment, like I said about not testing in production. So every single person who is pushing a chef change is trying to edit the same 2 files, which are essentially a big long list of constraints. So you run into issues with people treading on each other's work, people reverting other people's constraints, not being able to tell who's working on what cookbook when, so you both try and update it at the same time and end up getting somebody else's changes. It wasn't going to work well. We didn't actually get to the stage of having these problems because they were fairly apparent right at the start. This was not going to work for us. So there were several possible solutions. Solution number 1, go with it and hope for the best. We just use the out-of-the-box knife workflow. Ops code know best. They've written it this way. They must have done that for a reason, so we'll just stick with it and hope nothing breaks. Not a good idea. Option number 2, don't use environments at all. We've uncovered all of these issues. Why use environments? Let's just stick with our two individual chef servers, and try and keep them in sync. Option number 3, write a totally new workflow. Scrap environments altogether. Write our own thing from scratch. It's an open source product. Option number 4, tweak the existing one with some tooling. For anyone who's heard any recent Etsy chef talks, they'll know what the solution we came up with was. What we ended up deciding to do was tweak the existing workflow with some tooling. There's nothing wrong with the existing environment's workflow. There are just circumstances where it's not ideal. When you have 40 people all trying to update files at the same time, it doesn't work that well. But the fundamental concepts are all there. You're constraining your servers to only use particular versions of cookbooks. It's perfectly sensible. It's a really great feature. So we didn't want to undo all that work and write something we were going to have to support ourselves that was going to break compatibility with Chef and all kinds of stuff. So what we came up with was a tool called Knife Spork. I promised it was my last food-related pun earlier, but this is the name of the software, so I can't really not say it. Link to footnote 10. Spork is a wrapper around environments. It doesn't change the underlying behavior, but it does change the way we use it. So, as I said, wrap around standard environment workflow. Spork works with a 4-stage process. Check, bump, upload, and promote. Check is checking what state your cookbook versioning is in. Bumping is just a nice way of changing the version number and metadata to RB. Uploads and freezes the cookbook. And promote, which is the part that is probably most different from the standard workflow. This is where we set the environment constraints. What I'll come on to now is how that's been engineered slightly differently to work for the amount of people we have working on Chef. So I'm just going to run through a couple of screenshots quickly to show you what Spork actually looks like when you use it. This is the output of the check command. Fairly basic. It checks your current local version and it then checks the, by default, 5 most recent versions on the server. Just gives you a snapshot of what version number you're probably looking at, and also whether the version numbers on the server are frozen or not. If they're not frozen and you forget to change your cookbook version number, you can upload over the one on the server, and you've just pushed out your changes instantly without meaning to. Warning displayed at the bottom, your local cookbook has the same version number as the starred version above. You can't do this in one hit, as far as I know, with out-of-the-box Chef. You can check what version number your cookbook has, and you can check what version numbers are on the server, but it won't tell you when they're the same, and it won't tell you when the one on the server isn't frozen unless you go digging. So this was important, because a lot of the people we have using Chef aren't hardcore operations people. They're developers who want to make their own Chef changes. So they don't want to have to worry about this kind of stuff. They're not going to think about it the same way we do, with not being woken up at 4 a.m. in mind. So I've tried to make it as friendly as possible. It gives you nice friendly error messages when you're about to do something silly. This is the bump command, Knife Spork bump cookbook name, major, minor, patch, or manual, depending on what component of the version number you want to change. It simply tells you it's done it. Upload. Upload is essentially the same as Knife Cookbook upload, with the only difference being it freezes the cookbook by default. You don't have to specify -- freeze. Specifically because we decided we wanted to have all of our cookbooks frozen So we didn't want to be in a position where people forgot to do it and started treading over each other's work, because that gets us right back to why we didn't want to use the existing workflow in the first place. So minor tweak to Knife Cookbook upload to make -- freeze the default. Also removing the feature that lets you add the environment constraint in the upload stage, because we manage that later. But other than that, it's exactly the same as the built-in. Then the promote stage. There are two stages to this. There's promoting locally, which is Knife Spark promote, the environment you want to promote to, and the cookbook name you're promoting. But essentially, all this is doing, again, is adding the version constraint to the JSON file. It's just changing the version constraint in the file. It tells you saving files into foo.json. Promotion complete. Please remember to upload your environment file. The next stage, adding -- remote on the end, does that. It's essentially under the hood doing knife environment from file. The interesting thing about this whole set of tooling, initially it worked really well. It avoided the issues we designed it to avoid. What's particularly interesting in this case is how it's evolved since. We've been using Spark probably for about 9 months now, I think, and it's evolved a lot. There's been a lot of new stuff added that wasn't designed into it at the start. A lot of the input and work from this actually came from our developers. Jon Cowie, who I mentioned earlier on, who wrote the Knife Last Run plugin, he thinks about Chef a different way than I do. My specialty is operations. I think like an operations guy. Our developers use Chef, or think about Chef and think about code slightly differently to us. So a lot of the best suggestions came from developers, giving me fresh perspective on how the tool was going to be used and how we can make it better. It kind of evolved organically because it's not managed as a formal software project. We don't have project managers and scrum masters and sprints and all that kind of stuff. And it's open sourced. You can download Spark and you can use it yourself. What I want to go on to talk about now is the experimentation side. So we looked at the critical approach side, which was basically taking the existing workflow and modifying it. The next is basically now we have this tool, how we started messing about with it to make it work even better for us. One of the first things we were able to do, because we have the tool, is adding safety checks, which I'll talk about in a second. We also added a bunch of extra features to do new shiny things. But the safety checks let us avoid a lot of the issues that we found we were actually still having. People treading on other people's work, people making mistakes, pushing things accidentally. But now we have this tool that is designed for our specific workflow, for 40-odd developers, all changing Chef at the same time. It was kind of, rather than having to then try and bend the default workflow to our will, and having documented procedures everyone has to go through to make a Chef change, we just program it out of the way. So people don't have to remember this stuff. Like, a lot of these safety checks were added because operations kept screwing things up, and it's our damn system. First safety check we added, before promoting, check you've actually uploaded the version of the cookbook you're promoting to. Out of the box, you can set a constraint in an environment, say PHP must be equal to version 0.1.0. You then upload that environment file. There is nothing to stop you doing that for a version number of the cookbook that doesn't exist on the server yet. What will then happen is all of your Chef runs will fail with something like an invalid constraint error, and they'll just stop. They won't even go through the run. They'll stop at the start. Bang, all of your nodes have just stopped dead. We kept finding this happening because we'd mix up the steps, we'd promote before we uploaded, stuff like that. So what we added was a safety check. When you try and do a promote -- remote, checking PHP version 0.1.3 exists on the server before promoting. Any error means it hasn't been uploaded yet. It then finds, lo and behold, we haven't uploaded that version of the cookbook yet, so it stops you dead. It doesn't upload the environment, nothing changes. You then go back, you upload the right version of the cookbook, and you promote again, and it will let you. Sounds fairly simple. I mean, we could have written a procedure for this. We could have written instructions on the wiki to say you must do things in this order. But much though we'd like to think we're not, we're all fallible. We all screw stuff like this up, and we'll do it more than once. We did it more than once. I wrote the tool, and I did it more than once. So by adapting the workflow for our purposes, we were able to kind of add these checks in that were things we kept screwing up.